All right. I'm hoping this works the way I want it to. So good afternoon, class, or good evening, whenever you're watching this. I'm doing this live right now, but I'm doing this just so I can let the video save. So parents, if this showed up and you're wondering what's going on, that's what's happening. Students, again, that link will be there. You should be able to watch this video. And it's nice because I don't have any time limits on this, which is nice. So really quick, I'm going to talk about something called combining like terms. Okay, so that's today's lesson. We're combining, okay, putting together. So we're going to combine like terms. Okay, and today we talked a little bit about what that means. We talked about what it means, what like terms are, and how to combine them. Okay, so when we are putting something together, okay, we have to take terms that have the same variable expression, not just the same variable, but the same variable expression. And there's a couple of different examples of that. And again, I talked a little bit about what some of the rules are. So make sure you're paying close attention to kind of how I'm doing things. The other thing too is you might see me looking at this kind of awkwardly. It's a mirror image for me right now. So I'm trying to look at the numbers on there and it's not working. So, but anyway, so let's talk about this first problem here. This is one of the simpler examples that we're going to see, where you have 3x plus 5 minus 7x plus 1. So it's kind of a jumbled mess right now. The way I describe this is if I go to a restaurant and let's say I order steak, potatoes, and broccoli, if I have the money for it, I don't want my steak, potatoes, and broccoli all to be mixed up in a mess and like just a gross, nasty, like it looks nasty, right? It's not appetizing. Okay, I want things sectioned off. I want my steak here. I want my potatoes here. I want my broccoli, maybe a little cheddar cheese on there. Okay, so that makes it look appealing. Just like in math, that would look nicer if these terms were together. Okay, it would make it look like less of a mess. Okay, so you learned back when you were in fourth grade, and I know this because I taught fourth grade. You learned that the commutative property of addition and the associative property of addition tells you that you can add things in any order. You can move them around, and it won't change the value. Okay, subtraction, that was not true until now, because you now know how you can change subtraction to addition. Okay, so the first thing I like to do is I like to make sure that I'm dealing with all additions so I can move things around. So I have a positive 3x here plus a 5, so positive 5, but I'm subtracting a 7. If I'm subtracting a 7, that's the same as adding a negative 7. Okay, so now I can move this around because the negative sign is going to follow it, and I have a positive 1. Okay, so now everything is in addition, which means I can now start to move it around. So the first thing I'm going to do is I'm going to put the terms together that I know are like terms, that have the same expression. Okay, so I have a 3x, I have a negative 7x. Okay, so I have my 3x plus negative 7x. Okay, I'm going to put the 5 next to the plus 1. Okay, so I've got at least, this is a little bit better because I've got the terms that are similar next to each other now. Okay, so all I did was change the order by changing subtraction to adding a negative number so I can move things around. Okay, so now I've done that. I put things in a little bit nicer order. Okay, so now what I can do is I can start to combine these. Okay, so I've got an x here and an x here, which means I can combine these. I don't have an x here, so I can't combine that with these. It doesn't have an x. It doesn't have the same variable expression, we say. Okay, so but I don't have a variable here, but I also don't have a variable here. So these I can actually combine as well. Okay, and everything is in addition mode here, so I'm going to bring down the addition sign. Okay, so I have 3x plus negative 7x. Okay, so I'm 7 in the negative. Okay, and I'm going to add 3 to that. So negative 6, negative 4. Okay, so I have a negative 4x plus 5 plus 1, which is 6. This is my simplified expression. Okay, I've combined like terms, and I've made this a little bit easier to work with. So I'm dealing with just negative 4x plus 6. Okay, I could also write this as 6 minus 4x. Okay, so like I said, order doesn't matter when you're dealing with addition. So as long as I make this a negative, I can move it around. Okay, but if I want to put it back and make it even simpler, I can do 6 minus 4x because it's the same thing. Okay, so again, that's a bit simpler. That's a little bit easier to see, and this is kind of one of the simpler examples that you're going to run into. Okay, things are going to start to get a little more complicated. We're going to start using the distributive property with this now. Okay, and the bell's going to ring, so I got to make sure that you don't storm in from study hall. So I got to get this done. Okay, so in this case, I'm timesing 3 by this whole thing. Okay, and we talked earlier today, I do have an x here and an x here, but I cannot combine these two because they're not the same variable expression. Okay, x squared is not the same thing as x. Okay, so I can't combine these two, and we're going to talk more tomorrow about why that is. Okay, so this is actually correct. I can't do anything more in the parentheses because I can't just add these two together. They're different. Okay, they're not like terms. All right, so the only way to bust this up and be able to make it simpler is I have to distribute this 3 to every piece. Okay, so I'm going to go ahead and do that. The 7 is just going to hang out over there. He's got no part in this right now. Okay, so we'll bring that 7 down and we'll mess with everything else. Okay, we're going to give the 3 to everything. So 3x squared. Okay, because 3 times x squared is 3x squared. Okay, 3 times a positive x is a positive 3x. And 3 times a positive 1 is a positive 3. And I'm going to leave my 7 there. Now, again, x squared and x, those are two different variable expressions. Okay, so these are not like terms. Okay, so I've got x squared here. I've got 3x. I've got a 3 and a 7. Okay, the only thing I can do here, because neither of these have a variable, is I can combine these two. Okay, I can do 3 plus 7, which we know is 10. I can bring everything else down. 3x squared plus 3x plus 10. Okay, and that's all I have to do. I've simplified the expression. I've combined like terms. I had to do a little work to get there. I had to distribute the 3 to everything. Okay, but then I was able to get that 1 outside. Okay, and I was able to times that by 3 and combine it with the 7. That's where I got the 10 from. Okay, I know it's a little weird. I know it's a little different. Okay, but again, we can't do anything in the parentheses, so we have to distribute to get rid of them. Okay, so the last one, this is probably the most confusing one. Okay, so bear with me on this. Okay, so I have a 2x plus 1 plus 4x plus 1. Okay, now you could distribute the 2 or the 4 to each of those. Okay, but one thing that people overlook with this is when I have 2 times x plus 1 and 4 plus x, or sorry, let me start over. So if I have 2 times x plus 1 plus 4 times x plus 1, these actually have the same variable expression. They both have an x plus 1. So I can actually combine these two terms together. I can take 2 plus 4 and have it equal 6. And these are both the same variable expression, so I can actually combine these. Okay? So if it's in parentheses and the same and there's a number in front of it, okay, and they have the same thing in those parentheses, that means they still have the same variable expression. The same thing is being done to that variable, therefore you can combine those terms. Okay? So if you took notes, pay attention the whole time. Again, on the left side of your 2-column notes, that's we've talked about this, but I'm just going to review this really quick. All of this should go on the left side of your 2-column notes. If you were, as you were going along, make sure you're writing on the right side what you're doing, why you're doing it, how you're doing it. Okay? So think about how you're able to do the things you're doing. Okay? Why you're able to do those things or what you did. If you don't know the answer to those questions, then you need to write those questions down and get them answered in class tomorrow. Okay? So if you weren't sure why I did something, say, Mr. Coffee, not sure why you did this, and then, of course, we'll get that answered in class tomorrow. Okay? If you took notes and you were following along, put a little coffee mug in all 4 corners of your notes so I know that we were together on this one. Okay? So good work. Hopefully you'll get your questions answered tomorrow, and hopefully this made sense. Again, this is more of an introduction. So tomorrow we'll use those Carnegie pages that are online, and we'll go through how to combine like terms. Good talk. It was fun. And I awkwardly stare into the camera while I end this. There it is. Yeah, I want